All right, Unit 3 is pretty easy. So what I did was compiled together the three biggest topics from Unit 3. So the biggest topics are the chain rule with composite functions, implicit differentiation, and inverse differentiation. So what I want to do is just walk through a couple of these problems with you. So this is where you're going to see your table. And again, a lot of the table questions used to be multiple choice, and it's really difficult and challenging to know what they are going to do with you. So basically this says find f prime of g of 1. So we know that with the chain rule, basically what we do is start from the inside and work our way out. So the first thing we're going to do is find g of 1 and replace it. So g of 1, according to the table, is 5. So we're going to put the 5 in there. And then what we're going to do is say, okay, what is f prime of 5? Well, f prime of 5 is negative 4. So f prime of g of 1 is really negative 4. Now here we have to be a little bit more careful. So we're still going to find f of 4. So we have g prime of f of 4. So f of 4, according to my table, is 2. So it's like saying g prime of 2, but that value is squared. So really we're saying g prime of 4, and g prime of 4 is 1. Okay. Here is a free response question. This was a free response question from, I believe, the 2012 AP exam. So it says the function is defined as the following from negative 5 to 5. Find f prime. So the first thing you want to do is find your derivative. So f prime of x is 1/2 25 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. And then we're just going to simply clean that up. So the negative 2 and the 1/2 are going to cancel, and you're going to be left with negative x over the square root of 25 minus x squared. And the only thing that's going to change now is here. Your original domain was from negative 5 to 5. Well, since the square root is now in my denominator, the domain is negative 5, not including 5, or negative 5. So that would be part A. And part A would probably be worth 2 points, especially because I think they might ask you about that domain. Part B would be write an equation for the tangent line to the graph at x equals negative 3. Well, in order to write the equation of a tangent line at a point, we need to know the original value at that point. So easy points, I need to know what is f of negative 3. So just going to plug in negative 3. So we get the square root of 25 minus 9, which is a nice perfect square. So you get the square root of 16, which is 4. So that gives me the coordinate point negative 3, 4. What makes that so crucial is that that coordinate point is my x1, y1. And then what else I need is f prime of negative 3. Well, I already have my derivative, so it's negative 3 over the square root of 25 minus negative 3 squared. So I get a positive 3 over 4. So that 3/4 represents the slope of the tangent line. So in order to get my final answer, it's y minus 4 equals 3/4 x minus a minus 3, so you get x plus 3. So your final answer is y minus 4 equals 3/4 x plus 3. So again, just talking about the points that they're going to distribute out to you, they will probably give you 1 to 2 points for the slope of the tangent, 1 point for the y1 coordinate. So this would be worth probably 2, where 1 point's coming from that, and then 1 point's coming from plugging it in. Okay. So differentiating combined algebraic functions, a very common mistake when applying the chain rule is forgetting to take the derivative of the inside. So we see this a lot with related rates, which we're going to talk about related rates tomorrow in Unit 4. So Unit 4 is a big one. Unit 4 is all about related rates. It's about optimization and just basically taking everything we did with derivatives and applying it to problems. So I believe since the AP exam is going to be open notes, open calculator, they're not going to ask you a lot of questions that are simple. They're going to ask you those conceptual questions. Do you understand terminology? Do you understand concepts that can't just be regurgitated? So implicit differentiation is essentially taking the derivative of both sides. So this is, the case where we have to take into account dy, dx, 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 and then in related rates, it's x dt, dy dt, etc. So this is the related rates aspect to implicit, where this is implicit on the most basic level. So let's look at an implicit problem that is relatively simple. So we have x squared, which we know its derivative to be 2x. And then inside here, we have two problems being multiplied together. So this is a product rule. So it is the first, which is x, times derivative of the second. So the derivative of y is 1 dy dx, plus the second, which is y, times derivative of x, which is 1, plus the second part of that problem. So the derivative of y cubed is 3y squared dy dx, and the derivative of 0 stays 0. So in order to find the derivative, or dy dx, which is what it's asking for, we need to isolate dy dx. So what we're going to do is get rid of this 2x, get rid of that y. So that's going to leave me with x dy dx plus 3y squared dy dx equals 2x plus y. Then you're going to take out that GCF of dy dx. So you get dy dx, x plus 3y squared equals 2x plus y. And then to get dy dx alone, you're going to divide by the GCF of x plus 3y squared. So dy dx in this case is equal to 2x plus y all over x plus 3y squared. So derivatives of inverse functions, if you recall the derivative of the inverse, so it says let h and g be inverses of each other. So if g of 2 is equal to 7/4, that means that h of 7/4 is equal to 2. So basically whatever the range is of the original becomes the domain of its inverse. So if you want to find h prime of 7/4, whoops, that is really like saying you want to find 1 over g prime of 2. So that means that I need g prime of x. So the derivative of g would be 3/8 x squared plus 1/2. And then I'm going to find g prime of 2. So it's 3/8 2 squared plus 1/2. So 2 squared is 4. So you get 12/8 plus 1/2 in terms of eighths would be like 4/8. So you get 16/8, which is 2. Okay. And then down here, we're going to look at a limit of a log. So basically, this is, think about it in terms of the rule. So whatever is here is your f of x. So then your answer is just going to be f prime of x. And in terms of this problem, it's really kind of like -5 log, sorry, not negative, 5 log of x. So you just need to know, okay, what's the derivative of that? Well, let's look at this as if it were really just the f of x. So remember that 5 can almost be like factored out. So then it's f of x plus h minus 5 f of x all over h. So the x in this case is 2. So what we're going to do is kind of think of this as x squared in a way, or you can think of it as x. But basically what you're going to do is you're going to say, okay, well, what is the derivative of the log? Because that's what this is really asking. Well, derivative of log is the log of that problem all over 2 times the natural log. And we know that the log over the natural log is going to leave us with an ln. So in terms of this problem, my x is 2. We're looking for something with a 5. Remember, the negative is part of the problem. So your answer in this case is B. Again, it's not going to be multiple choice. If anything, they're going to really ask you to interpret what is f of x from the definition of the derivative on this exam. Okay, I love this question. I actually already did it. You can see I got the correct answer selected. So this is not just to find the first derivative, but to find the second. So you have to take that notation into consideration. So the first thing I did was bring up my exponent as a negative. And then the first derivative is -3 times 10/3 x to the -4. So that's why I'm leaving the d dx here again. So I took the derivative once, but I need to take it twice. So really that d2 dx squared is kind of like saying d dx times d dx, hence the d squared up top and dx squared down below. So I need to take that derivative one more time. Well, those 3's canceled. So then you get -10 times -4 x to the -5th, which gives you 40 over x to the 5th. So often we get to this point here and people want to pick D because they don't realize that you have to take the derivative twice. And then here's that extension style question. It's asking you, okay, first off, what is the second derivative at a particular point? So the first thing you need to do is find the first derivative. So the first derivative is 4x cubed plus 2y dy dx equals 0. I'm going to solve for dy dx. So I get -4x cubed all over 2y. It'll be easier if you simplify here. So that gives you negative 2x cubed over y. And then in order to find the second derivative, you have to take the derivative of that, which is a quotient rule. So it's ho d high minus high d ho all over ho ho. And then this is where you got to remember the little trick. This plugs in for dy dx. So you get negative 6x squared y plus 2x cubed times negative 2x cubed y all over y squared. And then we need a common denominator, which means this term needs a y. So that becomes y squared over y. And then we get negative 6x squared y squared minus 4x to the 6th all over y cubed, because the y over the y turn into itself. And then the last thing you want to do is take out a GCF. So I can take out a negative 2x squared. And what that's going to do is leave me with, well, actually, it doesn't even matter because it wants me to find an answer at a point. So I can almost stop here and just plug in. So d2y dx squared at the point negative 2, 1 is really negative 6, negative 2 squared, 1 squared minus 4, negative 2, to the 6th, all over 1 cubed. So here maybe it would have helped to plug it in, because if I'd factored it out, it would have left me with, let me just see here, it'd make it a little bit more complicated. So I'm just going to go back to plugging in numbers. Negative 2 squared is 4. 4 times 6 is 24. So you get negative 24 minus, well, negative 2 to the 6th, 2 to the 4th is 16 times 2 is 2 to the 32, 64. So 64 times 4 is 256, and that's still negative. So you get negative 260, 80.